So as I introduce, I'm going to be talking. In fact, let me just go ahead and go to the next one. Let me move your. So we're going to be talking about the silver species diversity. We'll talk about man's, and silver is only next to copper on the long relationship that man has had with it. We've had over 8,000 years of a wonderful coveted relationship with silver. We'll talk about how silver, more than any other precious mineral, has impacted the world events, development of countries, and even the development of empires. And this is much more even than gold. And I'll explain why as we go through this presentation, because I think the history of silver, not just the beautiful pictures, is what really makes silver so special, at least in my heart. We'll talk about its rarity and world production, the wonderful properties, and then last, as Cindy said, is born of how it came about from the stars, and then how it's actually brought up to us into the unusual happenings. So these are according to Mindat, and this is relatively new, is that when last time I gave it, it was about 170 species of silver. Now there's 191 silver species of silver. And these are some of the ones that we'll go through, some of the different species. Let me go with my laser pointer. We've got the chlorogyrite, which is a halite. There are 7 varieties of halite silver species. We'll talk about the acanthites and there's 100 of sulfide minerals. There's 173 varieties. We've got the elemental silver or the native silvers. There's 7 different species, and that includes some of the species that goes along with the mercury. We'll talk about there's the tilsmonite, which is a phosphate arsenate vanadinite, which has 2 varieties. There's also up within those, we've got the very, very rare species of this unit. And I'm having some, let me just get back to the quetzalcoatlite, which is this one here is quite rare. It is considered to be, it's the only oxide species. They do have it in Utah, but this specific picture is one that's down in Mexico. There's also a argentgericite, which is a sulfate, and there's only 1 variety of species, and this is also from the Tintic area in Utah. We'll jump into, and what I'd like to do on our presentation as I go through is I go through a technical area. I'll try and break it up a little bit and show some pictures of some of the different species, the wonderful, wonderful different specimens of it, and kind of give you a little bit of break from what's kind of really been going on. And we'll start with this because this to me is really quite amazing, in that if you take a look at copper, particularly in native copper, it goes back to the 9th millennium. So about 11,000 years that man has been working with native copper. And the only one that has the next related one is native silver, and it goes back almost 8,000 years to the mid 5th century millennium. And BCE, you guys are probably aware of it, stands for before current era. And that is basically, instead of going to the BC before Christ, well, then they basically made it to where it was more international. And so I'll be using BCE in most of our discussions. Gold, 5th millennium, and then the actual dealing with some of the smeltering gold or smeltering silver goes back over 5,000 years, almost 7,000 years, to the 4th millennium BCE. It really kind of got started in the area that makes up kind of the original Greek city-state areas. And just behind, if you look at the lower tip of the peninsula of what was Greece at that time, if you're looking at from this, your area up in here would be the Athens type area. And there's a whole series of silver mines that were actually located in the terms of about somewhere in the neighborhood of about 600 to 700 BCE. And these are, this is just, again, just north of this in the peninsula here near Athens. And this is an old washing table that was used within in order to get, this is one of the mines, and this is a processing area that was used on it. These are the famous Laurentian mines. And it was also estimated that these mines between about 600 and 300 BCE produced 1 million troy ounces per year during their development. This is also some silver. This is from Syria, and this was actually done through the cupellation process. And these are also close to in the neighborhood of about 5,000 years in age. And then we get into a little bit later within these are Greek ingots of lead and they were actually separating off the silver from the lead and using it to during this cupellation process. And then they were actually then recasting the lead because it was used for water pipes and it was used for all kinds of other items. And I need to tell you a little bit more about the Greek involvement, because there was the Greek really, the reason why we know so much about the Greek culture today has a lot to do with the fact that they had the silver and what happened with the silver and within the whole, there was the Greeks themselves. In fact, let me go into some of the coinage that'll talk a little bit more about what was happening in the Greeks and the Ionian. Some of the oldest coins that were ever involved. This is Ionian, 650 to 600 BCE. This is electrum. It's a combination of silver and gold. Technically, electrum is at least 65% gold, and then the remaining is silver. But what happened is Themistocles was a politician, and with all the silver that was being produced in Greece, he when they were looking at using and they were developing some of what to do with the silver, he asked that they build syrenes, big ships, in order to, because the Aegean Sea, they had a lot of competitors, plus you had the issues that were related back to some of the other local areas of tribes that were not the Persians, that were not as friendly to them. And when Xerxes later would invade Greece with his huge battles, and you guys have probably all seen or heard about the movie, the 300, the folks that they actually did, the Persians, when he invaded Xerxes, they had land success, but they were defeated at sea by a smaller but a much better sailing group of using these syrenes that were actually built using the silver that was mined at these Laurentian mines. And so there's we know a lot about the Persians because of what happened later on, but we know a whole lot about the Greeks because they actually survived this major invasion by a much more massive fleet based off of what they were able to do with silver and how it impacted their world. And when in their trading, silver became a standard for trade within the whole Aegean Sea area. And therefore, when we talk about a standard, gold was not the standard, but silver became the standard and became a very durable standard that lasted throughout the years. So as you go through it, the Ionian, the lion, this is the Delos, this is the lyre, which is the symbol of Apollo. We have the very famous Athenian owl. And this obviously would not have been so long or been a standard if indeed the Persians had conquered the day and won the days. But it was in circulation from 512 BCE to 50 BCE. So you're looking at almost a 500-year period that this coinage was the standard. Getting into, so this was a Roman denarius. So it was in, this is one that was in about 240, from about 211 BCE to about 240 after the Common Era. This is a Jerusalem shekel. So when they talk about Judas Iscariot and his 30 pieces of silver, this is from the time of when those, what it would have looked like and what was minted at that time. The first US silver dollar was in 1794. And you see some of these different prototypes of what was used. But this becomes one of the most important items. And I'll talk about this in just a few minutes. But the Spanish pieces of 8. In 1497, when the Spanish found all the silver at Potosi in South America, this became the standard world currency from about 1497 to almost 1728. And the reason why they called it pieces of 8 is they would split the coins, and this is how they would make change. And I'll also talk about this in just a minute. This is a Sicily, and this is a Chinese silver, and this is what they use as coinage or to build currency within China. Let's go into art a little bit. This is Ionian Greek. So this goes back 8,000 years, and it was a silver-plated bull. It was the largest silver-plated statue that has ever been located, much less that goes back to that period of time. Incas, because they did have the native silver in South America. So this goes back to 1400. So you're talking about 1600, we're talking about 16,000 years when you start talking about all this, the different in the time periods of this in the BCE. A kneeling bull from the Mesopotamians, beautiful, beautiful kneeling bull. Hold the wine. You have one of my favorite. This is the Samaria. This is a gold, copper, and silver ram in thickets. So you got the silver that's on the outside, and you have the gold that makes up the bushes and makes up the overall head. And then this is a Persian silver man, bearded man. That's 300 BCE. So you're talking about, somewhere in 2,300 years. Additional art. This is an Egyptian about 1200 BCE. And what they believed in is gold was considered to be the skin of the ancient Egyptians, but their bones were made of silver. And so they did have quite a bit of silver. And then this one was beautiful, beautiful display of gold handle. And then this beautiful silver vase. You have Horus. This is also Egyptian. This is a Horus, a falcon god, and he's got an Egyptian crown on his head, very unusual. And what a lot of people don't see, because everyone thinks of King Tut, but in 885 BCE, the rulers of the 21st and 22nd dynasty were buried in silver esophagus. Just absolutely gorgeous. Look at the work in this area and the gold inlays. Just absolutely beautiful, beautiful silver work in Egyptian and some of the other early cultures. This is where I'm getting back to kind of what was happening. And so not only did silver bring about and help the rise of the Greek Empire, but later on, it also helped bring about the Ottoman Empire, and some of the different cultures. And what this graph represents is the different trade routes. And so you have both the Silk route that you see that's overland, and then you have a lot more of the spice route that was actually formed. And what was really kind of happening here is a vast majority of the silver that came in between in the neighborhood of about somewhere at about the years about 1400 and well into the 1600s, well into when we were actually discovered the silver in South America. A lot of the silver that was mined ended up in China. And the reason for that China is, and you can see this, we had clothes, we had silver, you had different soaps, you had incenses that would start from here and that would end over. And then in China, they would trade for it for the lot of different porcelains, perfumes, silks. But what was happening in China is, and you kind of think about it, is why would you transport, why would they end up with so much silver in China? The reason for it is it's twofold. China based a lot of their economic decisions based off of the availability of silver. And they also passed in 1580, they passed what they called the Single Whip Reform. And the Single Whip Reform Act said that if prior to that, you could pay your taxes based off of what you did as a living. So you would, if you were a farmer, you would pay your taxes with whatever you grew. And that could be wheat, that could be other items. You could pay it with chickens, you could pay with it. But in 1580, the government, when they passed the Single Whip Reform, said that you could pay your taxes in silver. And silver, because they had quite a bit of gold in China, but they had very little silver. So a lot of the silver that was being mined in Japan and some of the other countries was coming into China. And then a lot of the silver that was being done in Germany was coming in and helped all the early settlements that actually happened, that was associated with the Medicis and all the other stuff that was happening through here as the bankers. That gold was coming from Germany, and then it made its way over into China, because in China, the ratio of what silver was worth to gold, silver was half as what was worth of gold. So it was a 2-to-1 ratio, where everywhere else it was a typically 16 to 20-to-1 ratio of what it was worth. So you could transport this silver, this very durable one, and you could use it to trade and use it to buy large, and then your profits that came back to you were just absolutely significant when you brought it back in through and into Europe. So, and this was also kind of the reasons why you had a lot of, when I talk about the Medicis and we talk about what was happening in Venice, and you talk about these areas in it, Venice was one of the first stop-offs in the area. So not only was the silver coming from it, but later silver that was coming into Spain was then coming through, because at the time, the Medicis and several of the other ones had agreements that they could come over, and they had exclusive agreements to where they could come in and they could trade and go on some of these different routes and go through Persia and go through India. Of all these that happened, one of the things that helped bring about the Renaissance period was that fact that everybody wanted to get in on what was happening in Venice and help get some of the money of what was helping in that. And that was one of the reasons why Spain agreed to pay for the expeditions to South America. And what they found in South America here, this is Potosi Mountain, and this is now a museum that is within the Potosi Mountains. The amount of silver that was mined and that was processed, 85% of all silver that was being circulated in trade came from Peru and came from Bolivia and some of the mines in the Zacatecas area. There was that much silver, and it also created that here in Potosi, in these areas in here, in fact, that the Spain actually built a mint to actually produce the pieces of 8, and that was circulated. And with 85% of it, it was the reason why Spain as a country now became so wealthy and became a world leader. And then all of a sudden now, of course, England that had a big stuff, they also wanted to get involved in it. So silver itself not only impacted the Greeks, it impacted what was happening in Europe. It happened what was going on in China. And it was the first real currency that established a world market. It wasn't gold, it was silver that established as a world market. More locally, what was happening here in the United States is this is a map of the exploration and settlements between 1835 and 1850, recognizing that there were 5 mining periods in the Southwest United States. The first mining period was the Spanish mining period between 1581 and 1820. And then Mexico got its independence from Spain in 1821. And because they were having problems, recognizing that all of this was considered to be part of Mexico, Mexico was having problems in dealing with the governments of the issues. So they actually invited settlers to come into the areas, into Texas, into this northern Mexico area, all the ways over into California. But you also notice that at that time, the Santa Rita mine, a big copper area where they also were mining, some areas were there. And it also, if you look at here, you see Virginia City, because, and this gets into the next period of the Santa Fe Trail area, which imparts into part of this. The Santa Fe Trail period was between 1820 and 1879. And that's where you get into the Santa Fe and the Humboldt Trail, Virginia City with the large mining operations that, as you can see here, you now start to see the Carson City. You see also all the different mines that the Comstock lode, and you start to see a little bit more of the mining that was happening in southern Arizona, as well as picking up some of so a large portion of the early overland rails and the exploration was actually based off of where the mines and where they were producing. Because if you're having a big mining camp and you have this large Comstock, by the way, was identified in 1858, you've got to get people there, but you also have to get the silver and you got to get the other precious minerals out of there. So a big portion of the overland stage here actually was based off of coming into Carson City and then getting the silver back up into San Francisco nearby in order to actually mint it and then send it out for the distribution. So a big portion. So it did have a large development within this area. The next period that was also based off of this same general area of 1890, the Iron Horse period, the precious metal period, which was from about 1879 to about 1882, which is when the majority of the rails were built that opened up the Western United States. And then you had the base metal period that was about from World War II, from about 1914 to about the beginning of the Second World War. And then you have the current period, recognizing that, again, the Comstock lode was identified in 1858. This then gets into my next period of what was happening in the Western United States, but this impacted everybody in the United States. Everybody knows and has probably seen the movie The Wizard of Oz, and which was based off of the 1900 book written by Frank Brahms, which was The Wonderful Wizard of Oz. And it was, like I said, released and printed in 1900. But what a lot of people don't know is that it was actually based off of what was happening in primarily the Western United States. And it had to do with the issue between the silver and the gold standard. And in the original book, she did not have ruby slippers. That was actually based off of the movie, but she had silver slippers and the yellow brick road. And this has to do with the whole issue of what was happening. And so let me kind of go through those real quick. So the Coinage Act of 1873 acknowledged that there was a gold standard over silver, but it also helped implement and set up what's called the Resumption Act of 1875 that stated that paper money or notes could be redeemed for gold or could be redeemed for silver. Then you had the Bland-Allison Act of 1878 that required the US Treasury to buy a certain amount of silver and put it into circulation as silver dollars. Then you had the Sherman Silver Purchase Act of 1890 that required the US government to buy millions of ounces of silver and enter it into the treasury as coins. So in that period, in about 1880, 1890 to until when the Silver Purchase Act was eliminated, they caused an artificial inflation of silver to in the neighborhood of about $1 to $1.50 an ounce, and it artificially deflated gold. What then happened in about 1890, toward the end of 1892, the U.S. entered into a Great Depression, one that was larger than anyone that they had seen previously. And what it was really based off of is that all the railroads had been put into place by 1892 to 1893. And a lot of the speculators that had so now the rail, since they were no longer getting land for their installations, then it started to trigger a reduction in the cost of the rail, but it also caused a tumbling in the agricultural prices, and people that had stock in railroads were now starting to speculate and started to try and figure out what they were going to do to try and protect their money. So what they started to do is they started to take their silver notes or their silver coins, and they went in and they were trading it for gold. And they were trading it in order, because gold has always had a better protection against the recession. Because of the recessions, President Grover Cleveland and some of the bankers that was happening then had blamed the whole depression, blamed it on the Sherman Silver Act. So one of the first things that, in fact, President Grover Cleveland, even before he was inaugurated, tried to get Congress to eliminate the Silver Purchase Act. He was successful in 1893, and what it did in that is it caused a huge crush in the overall in the silver and the mining, and it absolutely devastated the Western United States. So the whole Wizard of Oz movie was based off of Dorothy, who represented the farmers and normality. And she lands and she is given, she lands on the wicked witch of the East. Those were the bankers of the East that were promoting the gold standard. But she was given by the nice witch of the North, was given these silver slippers as a protection, and it would allow her to traverse the Golden Brick Road and traverse it safely in order to get to Washington, D.C. And it was the only thing that could protect her. Along her way, as you all know, she comes across the Scarecrow. The Scarecrow represents the farmers of the time who did not have even the wit to understand that they were deeply in debt and they were about to lose their farms. She also comes across the Tin Man, who represents the industrial worker. And in the original book, these guys have lost compassion for everyone else. That's why he didn't have had the issues with it. And the witch had actually cast a spell on him that every time he swung his axe, he would cut a piece of himself off, and representing the downsizing of what was happening within the workers. And the wonderful lion that had no courage represents the politicians who have the strength to stand up to the bankers and to President Grover Cleveland, but didn't have the bravery to do it. And so this is all about it. And in the end, it all comes back to the fact that when she does get to to get to the wonderful Wizard of Oz, who is represented by Grover Cleveland. He comes across as this majestic, wonderful leader that has all these wonderful powers, and in the end, it all turns out to be smoke and mirrors. But she always had the silver slippers, and all she really needed to do was that the silver slippers had the magic and had the power to return her to normality and turn the United States back to normality. All they had to do was deal with it and accept the bimetal policy and keep silver as one of the standards of our process. So it's just a wonderful parody of what was really happening there. Let's go back and look at some of the wonderful, this is silver with arsenic. What beautiful dendritic patterns. This is silver with malachite, beautiful silver crystals. This is galena, that is a silver bearing galena, which is a lot of what the Romans processed in both England and in various locations. And so it's hard to tell it because the silver is actually is embedded within the galena crystals. So it's hard to just look at it and say, well, yes, that's silver bearing galena. This is one for Miss Christina. This is a beautiful piece that she found up in Colorado, beautiful silver wire with malachite. This is from Michigan. This is beautiful, gorgeous silver in the crystalline form, dendritic. This is one of my favorites. This is from Mexico. This is a beautiful, look at the forms on this portion of it. And then this is also one of my favorites. This is part of Rob Levinsky's in the eye rocks. So this looks like to me like a sculpture that it's just so gorgeous that it is just a piece of art. It's just spectacular. Let's go very quickly into silver in medicine. Some of the earliest uses of silver was in water disinfection. In fact, Alexander the Great in 335 BC, when he would go on his campaigns, only stored and drank water from silver vessels. And the Greeks and Romans also stored water in silver vessels in order to keep them fresh. The ancient travelers in America, when they would go and head west in the 1880s, would place silver coins in their water barrels as a practice to help retard the growth of bacteria and algae. And then even NASA funded in the 1960s the use of silver to control microbial contamination in the water supply and the subsystems. In fact, the U.S. space shuttle fleet and the International Space Station still use silver in order to help purify the water within those systems. So it's long use. Also in wound treatment, it was known that silver was used for medicine and silver nitrate to help prevent infections and wounds. And perhaps one of my favorite ones and one of the most unique applications was Dr. Georgia Fix. Miss Fix, she was one of in the founding classes of the College of Medicine in Omaha in 1881. In 1890, 9 years later, she was out in Kansas and someone came in with a skull injury where it actually fractured the skull, and she successfully sealed up the skull by taking a silver coin and beat it into a sheet and then actually placed it on and over the wound and sold it within under the skin of this individual who I don't know how long he survived, but it was successful and he did live for some years later. And it's also been used in over 200 years for burn treatments. And it's also been used in some of the catheter associated for the bloodstreams and help keeping any kind of infections from within the catheters. From a modern demand perspective, it used to be that that photography used to be one of the #1 uses of silver when we had film. It's now by far the electronics, and the reason why it's in electronics is because silver is has the highest capacitance for transmitting electrons than any other minerals. It's even better than gold. It does tarnish, but it has the least resistance. And so it's used in almost all high-speed computer chips. It's used extensively for those. It's also, because of the electronics, it's also used in solar cells. It's used in everything, silverware, not much, coins and bars quite a bit, silver or jewelry a little bit more, but overall, there's in the neighborhood of the total annual production or use of silver is in the neighborhood of about 100,000 ounces of silver. Getting back to, again, some more, this is a Proustite class. This is a silver sulfate. So the minute that you add a little bit of arsenic, then the silver turns this clear. This is the ruby silver. There's 5 within this Proustite class. Isn't that just gorgeous? To think that silver could be transparent like it can be in chlorogyrite, or it can be in these Proustite sets. And this color is just, to me, it's just magnificent. It can also, I think this looks like to me the thorn of crowns. You've got this native silver, and you got these beautiful, beautiful acanthite crystals, the silver sulfate that comes off of it. This is argento pyrite. So this is the pyrite, and it's got the silver. It changes the crystalline form of the pyrite. To me, is just, again, just spectacular. You have acanthite. Acanthite comes in so many different forms. The habits on these can just be spectacular. This is one of the most beautiful acanthite crystals. This comes from Mexico. And you got these individual crystals. They're large and just absolutely. This is another one of Rob Levinsky's in IROX. This is one of his specimens that he has. And again, I think it's just absolutely spectacular. This is the acanthite. And you have these spears of acanthite, you have these feathers, you have these beautiful, beautiful different configurations that the acanthite can form. And then here is another acanthite that this one itself is from Morocco. And you've got this beautiful the acanthite crystal. So this is the same habit that you see over here, only this is a flattened habit where you have this beautiful, beautiful form. And then you got these smaller crystals that actually form. So all 3 of these are acanthite, but they have very, very different forms and habits that form on it. You then you add a little bit of copper and selenite, you can end up with this polybasite, which is also considered to be a silver sulfide. This one here is from Canada, and they often have this different iridescent effect on it. And then, of course, one of my favorites, and I hope it's one of yours, look at matildite, where you have a little bit of, you've got this sulfide, but you add a little bit of this bismuth, and you end up with this form. And this also has the chalcopyrite. Look at this, beautiful. They do have a little bit of matildite in Colorado, but this crystalline form doesn't just, wow, it just takes your breath away. It also forms like this tubelite, which is a silver, a lead, excuse me, and sulfur, where it forms these perfect, excuse me again, different, and it's also considered to be a silver sulfide. So all 3 of these last slides, these have all been silver sulfides. And they just, to me, just absolutely gorgeous. Some additional silver. This is now in the halides. This little portion right here is chlorogyrite. It's with conocalcite. This is from Chile. You have, a lot of people don't know that boleite is a silver, copper, lead mineral. So they have some of these beautiful specimens. This one comes from Chile, but they also mine them in Mexico. And some of these have hit some of the different rock shows, but it's also a silver mineral. But again, transparent, very beautiful, blue, semi-transparent. And then this is bromogyrite. So this is a silver with bromine. In this picture, this one is from the Victorial District here in New Mexico. And this is a picture that was taken by Jerry Cohn, a fabulous photographer, micro photographer here in New Mexico. You then get into this yellowish material is a miersite, which is a silver halite. And then the blue is azurite. This one's from Russia. And I think the contrast in color, again, just quite spectacular. Iodorite, which is the white that you see here, it's silver with iodine. And it's one of the other chlorides that are halides that are within the silver series. But can you imagine that that is actually silver and you can see through it as that? This is another piece of chlorite. This one is from in Germany. Let's get into a little more of the technical. Now that you had a chance to catch your breath, let's talk about its rarity. The rarest minerals that we know about are these minerals in here. You've got your gold, you've got your platinum, you've got iridium, you've got all the rarest ones here. You've got silver right up in here. Silver is 18 times more abundant than gold that you have as a general relationship. But the interesting part about it is that native silver, which is not the acanthite, but the native silver that you find in the wires and you find in those, only make up about 5% of all silver that is found. And silver right now in the United States and all over the world, and primarily in the United States, only 27% of all the silver is mined from what we call primary silver ores. Most of the others, it's a byproduct of copper mining, gold mining, and actually in lead production. In that fact, about 37% of all silver that is produced and mined today is produced from the processing of lead, of galena, and it's actually removed on that. So only a small percent. So if you take only 5% of it becomes native, then you find out very quickly that native silver in both either cubes or in silver wire is rarer than most of the gold species that you find. Silver as a whole in world production, we have produced between 1493 and 2017. Very little gold, silver was produced prior to about 1493. But we've produced over 49,000 million ounces of silver. But even at that, all the silver that's been mined to date would fit into a cube that is 185 foot on either side and is approximately 1,500,000 tons of silver would still fit over into that small an area. Some of the other portions of it, silver is so malleable that it can be compressed in such small sheets that 100,000 sheets would stand only about 1 inch tall. The only metal that is more malleable than silver is gold. On the mole's hardness scale, it's 2.5 to 3, roughly the same as calcite. It has a higher thermal conductivity than gold and copper, and has a higher electrical conductivity than gold or than copper or gold itself. And if you wonder about why, if you see silver, if we go back to some of the other items and you see silver and it's just that so bright, and it's one of the only ones, gold we say is a gold color, but silver is one of the only metals that does not have, quote, a color to it. And this is the reason why. Color is a virtual effect that's caused by the spectral composition of light that's emitted from it, transmitted from it, or reflected by it. Silver, which is this blue item, when it gets the electrons excited, it reflects back in the ultraviolet spectrum, which is invisible to our eye. So silver truly does not have a color, where gold, if you start looking at some of these other spectrums, then gold gets its color because of the way its spectrums and the way it's transmitted or reflected back to us, and how the electrons, when they get excited, what do they emit and the color that they do. And same thing with copper. So all the colors of the different aluminum, silver, rhodium, all of them all reflect back or emit light within the spectrum that we can see with our eyes, everything except for silver. So silver is one metal that truly does not have a color, or you could say that that is really the silver of the color of silver is and truly the silver. Let's talk about where it comes from. And I know that Dr. Seeds had a wonderful presentation here before that on talk about it, but I need to tell you about where it comes from and how it comes from the stars and how it's kind of formed. And this is a chart that gives you of all the different, the helium, the helium, the hydrogen comes from the Big Bang. A little bit of lithium comes from the Big Bang. You start to look at some of the green and start getting into what we call the low mass stars. You got carbon, you got the nitrogen, and you see a little bit of, when you start looking at here into silver, a little bit comes from dying low mass stars, and I'll explain that. And very little gold, just a small portion, only about 5% of the gold that we get comes from dying low mass stars. But what you see in here is that a sun itself, when it's during its hottest period, does not have the capability, it doesn't have the energy in order to produce gold or silver. And so it takes a very catastrophic event to produce the gold and silver that we have. And so I want to talk about what's happening when we talk about a little bit of this dying low mass stars, and then primarily this merging of this neutron stars, and what is a neutron star and how does it form. But let me talk a little bit about what the life and the evolution of stars. So we got this big stellar mass after the Big Bang. The dust accumulated helped form some small stars or large stars. It can be either one, and they're primarily made up of hydrogen and helium. And these hydrogen and helium, as you go through this nuclear fusion, you get it forms the heliums. The heliums can be formed together to and then form this beryllium. The beryllium can then be hit by helium, and it can form carbon. And then as it goes through, it keeps giving off the gamma. Carbon is one of the last. It can get up to iron, but you can't, in most of these stars, you can't get any higher than iron, because iron is at a point that is extremely stable. And these ones, they'll give off energy when they combine. Iron takes energy in order to combine them into future, and it requires extensive amount of energy. So you actually lose energy in the surface. But the life evolution of a small star, a small star is about our size of our sun to about 10 times the size to our sun. It'll eventually form what we call a red giant. And at that time, it'll actually consume the Earth. But then it turns in what we call a planetary nebula. And then it goes out to and forms a white dwarf. None of this has the capabilities of forming any kind of real has the energy levels in order to form gold or silver or platinum. It takes this route in order to really get the items to really form. And this is a large star. These are stars that can be 100 times larger than our sun. These will form super red giants, and then these super red giants will eventually get terminated in a supernova. This is where we start to get into what we call the dying low mass stars. And the end results of this one is, depending if it has 10 to about 40 times of our size of our sun, it can form a neutron star. If it is greater than 40, then it forms a black hole. Let's go into this processes of how it forms these items. And it gets back into these different processes. And I have to talk a little bit about what's happening in these massive stars and how it forms. Now recognize that a dying low mass stars and the neutron, they're kind of complementary, as I was stating earlier. So let's go back. So what I'm really looking at is this realm here. So this is a dying low mass star supernova. And then we're going to talk about what happens within the neutron stars and then what happens when these merge. When a massive star, when it gets toward the end of its life, what happens in this mass star, it's formed like an onion. It has been differentiated. You have hydrogen, helium on the outside. You start to get some of the neon. You get the helium, carbon, oxygen, and carbon. You can get magnesium. You can get the neon. You get the silica, and you have an iron core that's in toward the center. As this thing starts to the super red star, red giant, what'll happen is as it'll start by burning the helium and hydrogen on the inside. When it runs out of that material, it'll start to expand, and then it'll contract in the center. As it contracts in the center, it gets hotter. That allows it to start burning the next set of fuels. It starts combining, it starts burning the helium. And then as it gets even hotter, it'll again expand out and contract again, and then it starts burning the carbon. And eventually it gets down to where it's burning the silica. It cannot burn the iron as previously matched, but when it runs out of the majority of burning the oxygen, burning the carbons, then that gets at the very last stage. And what happens is this core will separate, and it will just collapse in huge. As it collapses in, they'll actually reach a period where it'll be the density inside here will be just so extensive that it'll be, you could take the density inside, you could take all the humans that are currently living, and if you compact them into the size of a sugar cube, that would be the same density as what you have here. Millions of times greater than the density of water. Well, as it contracts, it actually pushes the neutrons, or it pushes the electrons that are in the outer shell of these nuclei, and it forces them to combine with the protons on the inside of the nucleus. And when it does that, when they form together, they actually form a neutron, but they give off a neutrino. Now, this may be, it may be a little bit more than what you really want to know, but it becomes important because what happens when it does that and it gives off neutrino, because it's collapsed so fast that the outer shell also collapses in, and it collapses in so fast, it collapses in at about a quarter of the speed of light. It collapses in, and at the same time, the neutrinos that's given off on this interact with these outer shell materials and superheat them. So it collapses in, and then it just, as it superheats, the shock wave hits the core, it's superheated, and then it just explodes. So what's left is just this outer core, and all this outer shell is blown into outer space. What's left, depending on the size of the core, is either a neutron star or it's a black hole if it's got a larger mass. But when it does that, all those neutrons that are in those that get exploded out from the core intermix and start bombarding some of these outer layers, and starts bombarding the iron, and it changes the iron, and it also is a neutron absorption, changes it to a new element, does the same thing with carbon. So that's where you get the bombardment of the iron and bombardment of the carbon, is where you start to get that small amount of gold and silver that you saw from a dying low mass stars. The next stage, though, is this one here, is that about 50% of our stars are binary. That is, there's two stars within the same system, and they rotate around the center of mass. You have these beautiful neutron stars that have this huge density, that they're almost solid neutrons, incredible densities. This thing is 600,000 degrees Kelvin. It's rotating at hundreds to 1,000 times per second. It's rotating. As they get closer and closer together, if they're binary, then they actually get close enough together to where they don't collide. What they do is they rip each other apart. So the merging Dr. Seeds did a wonderful job of explaining that they merge. They don't collapse into each other. They merge by breaking each other apart and merging. But what happens then is you add neutrons to these assemblies. As you add the neutrons, then it explodes these neutrons into outer space. And they are some outer shells. As it explodes these neutrons, then these neutrons join together as they explode out, and you get these beautiful long jets of gold and silver and platinum and all these wonderful high elements because of this huge energy element of that. In fact, we think that within our solar system itself, the reason why we have gold and silver in the abundance that we have here in our Earth is because about 80 million years before the development of our solar system, so somewhere in the neighborhood of almost about almost 6 billion years ago, neutron stars exploded, and we were in the trajectory of this jet that produced. And we think that there was one, by the way, that was witnessed in 2017 that proved that this was Albert Einstein theorized this in 1916. It wasn't proved until 1917, or excuse me, 2017, that this actually occurs. And that we looked at the spectrum, the X-ray spectrum, and realized how much gold and silver was actually produced. So this is, and it's changed a lot of our ideas of what's happened, but it's also produced, like I said, this wonderful amounts of the silver. So now to give you again a little bit of a break from understanding what we call the rapid process is of neutrons, let's go over and look at some of the other wonderful items. This is a half-breed, so this is copper silver. This is from Michigan. This is a silver with mercury. Isn't that just gorgeous? It looks like someone cast a shoe or something, some kind of clog with it. And you also see actually some perovskite type ruby silver along with it. This is electrum. This is a naturally augmented alloyed silver and gold, and this one's from Telluride, from the Smuggler Union mine up in Colorado. This one is also, I love this one. This is what we call a silver, and what this is crustite, which is a silver gold alloy, but it has more silver than gold. And so then it's no longer electrum, it now becomes this crustite. And and then this one's with malachite, and then this one itself is from Namibia. You add a little bit of copper to it with the sulfite and the halpite. This one itself is also from Mexico. You add a little tellurium to it, you get hessite. This one's from Romania. This one, oh, I think this is just beautiful. It looks like the wires, but they're not the beautiful circular wires that you see. But this is benjaminite, and it has the bismuth in it. This is samsonite, and it has the manganese with it, and it's also got the silver on it. So it's pretty cool. Let's get back to what Cindy alluded to, which is the improbable events that bring. So we had gold and silver, as we talked about, was in our clouds that helped form our planet. Our planet differentiated. As it differentiated or got larger, the core got hotter. As it got hotter, it started to differentiate, and then it had a larger mantle section. Then you had the crust. Then you had this portion. We think that somewhere in the neighborhood of about 1 billion years, about 4 billion years ago, it was fully segmented to where you had the core, the mantle you had the lower mantle, you had the upper mantle, you also had the upper stratosphere, and also you had the convections that was also started within those, but we still didn't really have a lot of, this was a stagnant plate that was on the outside. It was only when we got this bombardment that we think that was happened about 4.2 billion years ago, where we had these large asteroids with a silica core and ice on the outside that bombarded and sent these shock waves through that totally disrupted certainly the crust on the outside. And then you had the mantles on the inside, recognizing that we still think that within the core area that there was enough gold that we think that there's approximately a 3-foot layer of gold that goes all the ways around the core section. And if you were to take that gold and bring it up to the surface, it would form about a 12 to 14-inch layer of all of our land surfaces, not the oceans, but our land surfaces would be covered with this 10 to 12 inches of gold. So we have quite a bit of gold that was actually caused by this emerging of these neutron stars. The question now becomes, the vast majority of it has been moved to the core. Now the question is, how do I get it out of the mantle, and how do I get it to where it comes up to the surface that we have? And that is indeed where you come into this. We're the only ones that have plate tectonics. Of all the planets that we have within our solar system, we are the only ones that has plate tectonics, which makes us very unique. It's also the reason why if you ever get approached and say, hey, invest of mining of gold on the moon, don't do it, because we actually have a higher concentration of gold in our seawater than what they have in the moon. And the reason is because of this, is the moon does not have plate tectonics. So does it have gold near the core? Do we think it's differentiated? Absolutely. Is it up on the upper layers? Very little, very, very small percent of what was happening. So we know that plate tectonics was quite well developed somewhere in the neighborhood of about 4 billion years ago. And we actually find some pillow basalts in the Greenland and Iceland area that indicates that we had indeed plate tectonics somewhere in that time frame. When exactly happened, we don't know, but this is currently what we currently think. The next portion of it is, how do you get it up to the surface? You have it in the basement rock. You now have to get it up onto the very surfaces. And that's, again, where the plate tectonics happen. And in this case, we're kind of demonstrating how it happens. You get this plate that's being subducted. You got the land masses. You also have a lot of the volcanics. You've got, as it comes down, it melts. As it melts, it actually sends up some of the materials that's joined with the melt of the plate, comes back up, that's carrying the gold and silver, and it comes up within the volcanics and actually comes up to the surface. This one here is showing that as this plate has subsided, then you start to get these accreted land masses. This one will eventually be accreted onto this land mass. So you end up with these zones that have this gold and silver, this volcanics and silver, gold, and you also end up with some of these areas with the volcanoes and hot springs. You then start to get these hot springs, and you start to get, as this hot water, this epithermal water comes up to the surface, it's carrying the gold and silver with it. You start to have the boiling point, and then you start to have the alteration zones. And so you get this area that's within an area, I'm going to say between about 200 and down to about 450, where you get this silver and gold precipitates out. You start to get the zincs, and you get some of the others, the coppers that precipitate out below it. And then eventually you'll have erosion that'll erode this area off and make this gold and silver, makes it available to those of us on the surface. What this means is you need to look for where the gold and silver mines. This is a USGS map of the domains, the basement domains, and it also overlays the mineral deposits. So this becomes very critical in looking at and understanding. If you wonder why we have a lot of the silver and gold mines, which are this orange and red, you've got a lot of orange and red. So you got this mineral belt laminate, which is a weak point, which has a lot of volcanics that runs up through Colorado. goes down here into the Crete area where you had some of the largest volcanoes, the largest that have ever been, the largest calderas in the world are right down here in Crete. About the same time these ones were going off at about 34 million years ago was the same time that we had them coming off down here in the Mogollon, Dado-Mogollon area. That's it. And then you have a lot of these then were also formed as part of the Rio Grande Rift. And a lot of this gold and silver had to do with the fact that if you notice these different colors in this basement domain, when we were forming the Wyoming and the Goose Creek area, this was a craton. This was a very stable craton when it actually joined in with some of the Superior, and it joined in with some of the other portions that helped make the Canadian Shield area. So this helped form, and what happened was these are different domains that were picked up. So you have this domain here that's called the Great Plains. You have the Mosel zone, and then you have this area that actually helped form a large portion of the central U.S. You do see some of these that actually occur out here in the east and in your area out here as you started to get into some of this, the Shawnee, and you started to get some of these different accretions on it. But what was interesting, what was most portion about here is a lot of this area that was picked up in southern New Mexico, portions of Colorado, big portion of New Mexico, big portion of Arizona, and all these that form in Nevada, and all these that form here in western Nevada, and also in California. These were all smokers. These were islands. These were part, if we come back to this island, we picked up these smokers that were formed out into the ocean, and the Farallon plate brought them over, and then they were accreted onto our continental masses. As it did that, it brought in all in our basement domain. We have lots of copper, silver, and then we had these later volcanic activities that came in, and it brought it up from the basement rock, brought it up to the surface where it could be mined. And that's what you see in all these different mining areas is all, and you can see these basement terrains and how they form within these different areas. So this is kind of the end result of the takeaways that I'd like you to take away from this presentation is that silver and gold cannot be made in our sun. It was seeded to us by merging neutron star permissibly, but it was also seeded a little bit by supernovas that were nearby. So it's born of the stars, a very unlikely event to have been in the trajectory of 80 million years before we became a planet, to have been seeded with so much wonderful silver and gold and platinum. And then it went down to the bottom, and then to have the plate tectonics that bring it out to the front. And then the plate tectonics, because of the crustal extension, was also a big reason of why the volcanic activities have brought it from the basement rocks out into the surface. So it truly is what we talk about, that it was born of catastrophic events. The improbable happenings is that the gold and silver sank to the bottom to it, and which occurred within the crust. But then the improbable happening too was the plate tectonics and the volcanism that is a result of the plate tectonics that brought it from and up into the alteration zones. This is me at the University of Arizona, the Alfie Norville Gem and Mineral Museum in Tucson. This is silver nuggets together. All three of these weigh 610 pounds of silver that was found in 2018 in the deserts in Arizona. And so that's one reason why they're posted there. But where else are you going to see a nugget of silver that's 600 pounds on that? So with that, I'm going to stop sharing, or actually I'll keep sharing, but I'll like to, well, let me do that in order so I can see who's asking the questions.
So I've got one. This is Bob Siminoff. I came back to this, even though it wasn't necessarily an easy thing, just because this has been a question and a subject I've had since I was a kid. I've been wondering about this. So first of all, thank you for the great discussion. It's been a long time coming for me, at least. My question is, when the neutron stars collided, or possibly at least some of the supernova blew out, I wouldn't expect that to be chunks of heavy metals at those temperatures and energies. I would have guessed, without any real knowledge, that it would be far more vaporous.
It was.
So then,
you're absolutely right.
okay.
So think about it this way. So the core is obviously a very solid. It's an iron core. When as it collapses in, you have solid material, but as it starts to go back out, it breaks a lot of times. So you have the neutrons that are coming, that have been relieved from they've been compressed. They're neutrons in the center. As they start to be relieved, they're relieving these neutrons, but the outside shell is gases, and some of those, the actual gases, are been broken apart down into their actual elemental forms. So think about them as gases that contain, in the more denser clouds, which are farther out, you got all these neutrons that are being shotgunned into these clouds that contain these particles of iron and silicon and carbon and others, and they're just being bombarded by this huge amounts of neutrons that have been released as a result of this explosion.
Right. So now,
but they are individual particles that are in the gas. Okay. And it's the same thing of even when they're formed in the gases, the nebulas that help form the planets and stuff. Those are individual particles normally left over from previous supernovas and nebulas, and they are particles, and they contain iron, they contain carbon, they contain all these other items. And if they were previously exposed to a neutron or other supernovas, they'll even contain some gold, some silver, and some in a very, very small amount. But there are particles of it. But you're right, the ones that are right by the core, it's absolutely individual neutrons and individual protons and electrons that have been liberated.
So the part that I'm missing then, if we've got sprayed by metal gases, I still don't follow how we have concentrations of it deep in our Earth. I understand that once you have a concentration of it, it can come up to the top through various plate tectonic activity. But if we're sprayed by these gases, I don't see how they congeal in this mixing bowl of molten rock to become concentrations enough to become.
Bob, think about it as individual particles, because think about it, when a neutron stars collide, again, they're just neutrons, but these neutrons join together because they're so tightly compacted and they're such high energy that's the reason why they very rapidly form. In fact, let me, I could go back to, but what happens is these neutrons form so fast together and they're bombarded so fast together that they don't get a chance to release even the gammas. So they go almost instantly from a single neutron. They get bombarded, and they actually end up forming these heavy metals, these golds, these platinums, these silver. They form these particles, and as they go out, then they cool down and they congeal and they join together.
Okay, now you
and then they hit the Earth, but the Earth is now just gases and particles. And it's just like our iron core. As we heated up and started to differentiate, then as like the iron went toward the center, so did the silver, and so did the gold, and so did the platinum.
Got it. So it all adds up now. We got blasted by a heavy metal meteor shower, basically.
Exactly.
I think what part of what Bob might be missing, is that all this happened before the solar system formed. So you have the supernova going off, and it sprays out the big cloud
Yes.
of hydrogen, helium, carbon, nitrogen, oxygen,
Yep.
then iron, then neon, silver, gold, everything else, and that's all out there as lots of gas and dust. Um, and then at some point, probably set off by a shock wave, this cloud starts to condense
Yes.
into stars and planetary systems, one of which is our own solar system. So you've got that the silver and gold out there with all the other stuff that went into our solar system. Um, um, and then it was as the Earth formed and the heavy stuff sank towards the bottom, and the light stuff, the silicates, floated up on top. So
Yes, and that's exactly right, Jeff. Recognizing that our star, our solar system itself, is at least a second generation, but it's most likely even a third generation star. As but we don't know for sure, but we do know that exactly as Jeff said, is that it was probably by shock wave from a local supernova is what actually started to help condense this other supernova dust or nebula dust together that actually formed our planet. And then sometime again, we think that, by the way, that this neutron star collision was about 80 light years away from our current locations. So 80 million years and in the neighborhood of about 80 light years away that helped form it. Otherwise, it would have blown the dust a heck of a lot farther away, as Jeff is getting at. These are incredibly cataclysmic events. I mean, just we're the Earth itself is like a single particle in this overall event.
And if you think about it, 80 light years is not that far away.
It's not. It really isn't. And it's closer than what we think our nearest black hole is, which is we think about 800 light years away. But by the way, the black star or the black hole, that is when you have a larger mass. So a neutron star is a relatively low mass volume. Black hole is a larger mass, but what's interesting, and we've been able to prove it scientifically, even though it has a larger mass, the overall compaction and volume that it takes up is smaller than what a neutron star is.
Sure.
So that's why they talk about a singularity.
Yeah.
So did that answer your question, Bobby? It's a wonderful question, and that's one reason why I spent a little bit more time with it. But it's really a program that you could do by itself just to understand the rapid process, or even how the slow process actually helps the neutrons and how you end up forming some of these heavier elements. Because the slow process can also do it, but it takes millions and millions of years to do it. In this rapid process, it can take mere microseconds.
Yep, that makes sense to me.
Well, thank you for that question. It's an excellent question.
Well, thank you for the explanation. I'm all set. I've achieved my life goal. I'm done.
Well, glad to be a pleasure to have been part of that. How about some other good questions? Scott, I know that you've got some good questions.
I guess I'm still not 100%. If stuff got settled for a while, kind of uniformly while the Earth was molten, I would think it would sort out by mass.
It does.
And then the deepest stuff, which silver is kind of in the middle of the periodic table, but the deepest stuff how does that get to the surface in concentration?
Some of that has to do with because when we started, you figure that when this stuff happened about 4.2 billion years ago, we weren't as settled. We're settling more and more every year. And in fact, we'll probably disappear in the red giant that will form our star before we actually, fully settle. And so if you think about it, when we think that even when we were originally, you start talking about possibly we were formed somewhere in the neighborhood, or our sun was formed about 4.5 billion years ago. Our planet was after that on it. So if you start talking about starting being bombarded by the Great Bombardment or some of these others in the neighborhood of 4.2, 4.3 billion years ago, we weren't as settled as what we are anywhere close to now. So, and some of that material, obviously, as it's still settled, didn't always go all the ways, because obviously it gets locked up, because as you well know, basalt being the first mineral that's there, it will tie up some of the other heavier concentrations within it until it breaks down and starts to settle. So the settling is not all at once. It is intermixed within it, but it is also gets concentrated as it goes down. Then the pressures and temperature allows it to end up being dissolved within the waters that are within the mantles, and then those get moved up into our basement rock and then to the surface using the plate tectonics.
I've got a question.
Yes, sir.
Yeah, when you look at the map of all the gold mines, we see that there's the precious metal mining is a huge thing all up and down the East Coast, and then it just kind of works and gets kind of sporadic. And there's still a few little spots here on the East Coast, but for the most part, the East Coast is it seems to be underrepresented. And I can certainly understand if you're sitting on the craton and there's no volcanic activity, that there's nothing to dredge up the lower levels of the mantle material, which contains the gold. But when we get out to where we are on the Piedmont, we're in the remnants of a rift zone, which was plenty volcanic.
Yes.
It's had lots of time to erode. Where's
Yes.
all our gold?
It's all it's covered by sediments. And that's the big part. So we don't know about the volcanology of what happened in central United States in the area. We do know that there's thousands and thousands of feet of sedimentary materials. If you look at Kansas, you look at Texas, you look at all the stuff, and you're going to have to, there could be stuff there. We don't know what happened early within the volcanics of what was maybe happening, 2 billion years ago, or even as our craton came together. We do know what's happened within our craton. I'm going to say in for the most part, the last really billion years, and really pretty well within the last 500 million years. But that's what happened before that. Is we think that it started out as a basalt ocean that went around that was fairly flat. We think that occurred for quite a while. You then, because of plate tectonics, you started to have microcontinents, and you started to have other small things that would start to be formed. A big portion of the cratons that formed the Canadian Shield area or the Wyoming plate area that these basalts actually form on it, is those were actually very stable, and a lot of those were actually even though they may have been some of the original, they may have accreted from islands and even island arcs, but they were altered as a result of their stabilization, and they're brought together, and they were altered primarily because what cements them together, all these little island arcs, is granite. So this granite comes up, cements the stuff together. So you end up with this very stable, but primarily feldspar type environment and not a whole lot of this gold and silver that was brought up within the water. Other areas that were also accreted area are now covered with sediments, and there may be stuff underneath it, but doggone it, we're going to have to get a whole lot smarter and cheaper being able to excavate down to those depths in order to realize it. You had the great activities in the West, like you're saying, you had the rifts. You also had where you had this proto-continent that smashed into eastern United States that helped form your green belt, and all your areas within those formed your the Sterling Hills and formed all those areas and gave you the mineralization. So that's the reason why you have some of those areas. But if you look at the Appalachians as a whole, where they were mountain forming and crushed and stuff, most of those are really, they're remnants of a primarily basaltic or granite type basement type rock. So, and I actually have a whole different presentation on exactly the question you just asked, John, and actually has to do with the accretion of our continental, our North American continental craton, how we came together, when we came together, and it ends with that same picture you just saw, but I explain how each one of those layers and each one of those sections, how it actually joined into our craton and why our basement rock has so much of those. And that would be a presentation I'd be willing to give to you guys as well. It's just that this one is, of course, I don't have a lot of fun silver pictures that go with that one. It's pretty much all technical, but it is exactly what you just asked.
Okay, thank you.
I know here on the West Coast, because I'm from Oregon, and live here in Oregon too now currently, that we had a lot of exotic terrains that smashed into our West Coast, and a lot of those divisions between those and the crumbling and the mixing of those has probably added to our situation over here, having all those gold mines and silver mines. But I would love to see that presentation that you just mentioned, since I'm an amateur geologist. So
and Beth, you're absolutely correct. In fact, up there in northern where you're at, you're right. There's a lot of very exotic terrain. We're even realizing now, as we go back and map the terrain, even associated with the Farallon plate, that the Farallon plate was probably 5 plates, because even the terrains on those is, and that's seen in that map, where you see that parts of California and Nevada, where you see this little terrain, and all of a sudden there's all kinds of gold and silver, and then the next one behind it has nothing, or the one in front of it has nothing. All that is based off of what was happening with that individual plate section and what was happening with, and you even have some other weirder stuff up in northern portion of it, just because you had more than just the Farallon plate that impacted what you were doing.
And you have the situation that in Oregon, you can't always find all that gold and silver because the Columbia River basalt covered everything up. And you can't get down through it without really working at it.
That's it. And they even, like here in New Mexico, where we have the large caldera, eventually, if we get enough erosion and if we're here long enough, there's a good chance that along the ring fracture and some of these other areas, that will be one day a wonderful silver and gold prospects that'll be up here. But we got a lot of erosion that has to occur between now and then in order for us to be able to access it.
And I have a question. I put it in the chat, but nobody bit. I think it was the picture with the binary system. And if you look real careful at the surrounding area, there are at least 2 faces there. There's a frowning one on the right-hand side, and there's a screaming one, really evident up above the binary system that you had. I thought it was interesting, but nobody bit on it when I mentioned it in the chat.
And I didn't see it because I had full screens on both of them.
Right.
So
you might want to take a look. It's it looks like that thing is really in a lot of pain.
It is. And like I said, and what happens is it does eject it out on an axis. And that's
Yeah.
one reason why John's question and Jeff's statement of it, it's not like it just, you know, when a supernova goes off, it's pretty much a round, explodes out. When neutron stars merge together and they collapse together, it shoots it out on an axis assembly. It doesn't go. And so it absolutely, when you have the binary, it's absolutely, and so that's when you look at it, that's why it's so remarkable that we have so much gold and silver here. Is we had to have been just right in that shotgun in order to have gotten that much gold and silver within our evidence. And so it's just, to me, that's, again, improbable, almost a miracle. And to have it to where it brings it up, almost a miracle. To have everything that comes together to what we have right now. And so that's why, to me, gold and silver, and particularly silver, is just absolutely so remarkable. And while it just, again, I look at these and going through this presentation, my little heart just pitter patters, just looking at these beautiful, beautiful specimens of the silver, of what's going on in the different habits that it forms, truly. And that's one reason why Christina and I have been doing a lot of looking at some of these different locations, and it just, wow, when you find it, it's like, wow, I got a little piece of a star here.
Another comment, another facetious comment. Is it possible that Dorothy's slippers were ruby silver?
Nope.
Now I'll be quiet.
Not in the book. They wouldn't stay together that well. But yeah, it is a good book when you read Brahms' original, and when you see it like this and you read through the book, it's still, you look at it, it's like, doggone, you know what? That makes sense. But it is really is, you know, and of course we have in 1900, we went to the gold standard, and of course then we've left that as well. But you can just imagine their panic of when you look at what Cleveland did, and you realize that when people was trading in, there were rushes at the banks, there were rushes at the reserve, there were rushes of stuff for people to trade in silver, to where our gold reserves got so low that they had to stop issuing gold because our reserves got too low and everybody was trading their silver for gold. So I understand why they did it, but the devastation that it caused in the Western United States as a whole was just absolutely incredible. Was just, I mean, towns just dried up, famine and all was just absolutely horrific of what happened in the West as a result of the repeal of the Sherman Silver Purchase Act.
Patrick?
Yes, sir.
I'm wondering about some of the other planets in our solar system. You mentioned tectonics as it being Earth unique.
Yes.
Has that always been the case, or was Mars tectonically active at a point in time and then everything consolidated? And if these planets, other planets, were not tectonically active, are they like just layered down to the center with the heavy stuff, and then going to the lighter stuff as you get out?
That's what we believe, David. Now, there is, for example, we know that some of the moons of Saturn and some of the others do have some volcanic activities going on, but it's primarily gases and stuff versus the magma. But we think it's exactly what happened to us. And that's one reason why the model that I showed you, the Able model, is really unique to the Earth. We know that a lot of these planets are differentiated, at least, you know, Mars, all the rocky ones that are in the front. The gas ones we think are maybe not obviously the same way, but the rocky ones, but we don't see any evidence, and none of our satellites and none of our imagery has shown that there's any plate tectonics that has occurred on Mars, Venus, Mercury, any of these, the rocky planets. It looks like that the Earth is just very unique in that feature. But we also think that because of the plate tectonics, that helped form the evolution of life, and that plate tectonics really add, and I think I showed it to you guys, the evolution of minerals. Life co-evolved with minerals. And that may be one of the reasons why we may find some stuff on Mars. We may find some stuff deeper down in the stuff, but that may be part of the reasons of why life has just exploded on Earth. Also has to do with the fact that the plate tectonics, the volcanism, and all the other activities that's allowed these things to come together and allow the evolution of minerals, but also the elements themselves.
Thank you.
Hey, Patrick?
Yes, sir.
I have a question. On the geological map that you showed near the end, I think it was like 2 or 3 slides from the end. And the caption started out with silver, gold, and platinum group elements.
Yes.
But then it had CuCu, followed by Zu. Copper I could see, but is there why is it repeated, and what is Zu?
Let me get to it. And okay, so it's not Zu, it's okay. So the Zu is actually that is so this is what, by the way, the PGE, are you familiar with the PGE, what it stands for?
Yeah,
It's a platinum group
yeah.
elements, which is palladium, platinum, uridium, osmium, rhodium, and ruthenium. When you get into you got the copper, and I think that it was copper, and I think it's copper. The Zu, that's a good question. I'd have to go back to the original. You got the iron, you got the moly, you got the nickel, you got the lead, you got the zinc, and you have the unclassified. I'd have to go back and relook up what the Zu stands for.
And with the copper, why is it, if that is indeed copper, why is it CuCu instead of just?
That's a good question. I suspect that the Zu is actually a series of uranium.
Ah, okay.
And that kind of makes sense when if I look at it, and I'm pretty sure that Z is just basically just the series for uranium. And why copper is listed twice, I'd have to go back, and it may be just in error, or it may be talked about that it's copper porphyry versus copper as an element.
Hey, thanks.
Brian Silver, as it turns out here. I don't have a question, but I wanted to thank you. I just turned 80 and my life has taken on a whole new meaning thanks to your presentation tonight. Thanks very much.
You're very welcome. And like I said, it was my pleasure. But like I said, Mr. Silver, this is truly, this is my passion, is not only minerals, but really the silver species is just, I just absolutely just adore.
Well, I'm signing up tonight.
Oh, very good. Any other questions?
Patrick, this is Cindy. I will be in touch with you about the North American accretion development. And to piggyback on John and I think some other people's questions, it just that I think it would be so interesting to see maybe USGS puts out a map of like silver mines worldwide, to see the correlation between known faults and plate tectonics as we understand.
They do have one, Cindy.
Awesome. I figured they did.
But this one, and the reason why I show this one is this is from a different report from USGS. The one that has the accretions of and the development of the continental one is by the way, this is all new information. This is all information that started to be developed in 2013. And it really came together in 2018 and 2019. So this map that you saw is from a different report, but what it does is this one report that, and what I do is I take all the graphs from the other report, show how everything accreted, and then bring this other one in to show how the actual plate tectonics and this accretion, how they work together in order to come out. And by the way, the reason why I was so interested in this is at the New Mexico Mineral Symposium several years ago, Virgil Luth, Dr. Luth made a comment. He says, the reason why we have so much of the copper in southern New Mexico and southern Arizona has to do with the fact that we picked up all these smokers. And from that, it was like, well, okay, well, that kind of makes sense. But how does that really, that is part of the base continent. So how does it get to the surface, and how does that relate back to the other accretions that occurred in California and Nevada and the other part? So it was that one comment that got me interested into it. And now it has brought the picture of silver and the picture of gold mining. It has brought that all together and helped me form. And I gave, by the way, Kathy was at the last year's Tucson show, but I don't think, Kathy, you came to my presentation on the continental growth of the Laurentian craton. But I actually gave it at Tucson, and one of the folks was actually John Rackavan, which everybody knows, and is now the director of our museum. He actually sat in on my presentation and came in, and also Ed Raines was part of that presentation. And he has asked me to give that presentation to the entire Friends of Mineralogy of Colorado. And in fact, I will be doing that. I'll be giving this silver presentation in the first week in December, and be giving that one, I think, in January, giving the craton one of how everything pulls together. So, because it is, when you see all this, a lot of the stuff that you guys involved with in the mineralogy all comes together from a bigger picture perspective, and you get a much better, and I think a more appreciative understanding of our wonderful world.
Absolutely. Thank you so much, Patrick. Thank you.